Welcome to Module 5, Lesson 16, Methods for Selecting a Random Sample. I've mentioned this idea of random sample quite a bit in the past during this Module 5, and its importance to statistical research. And today we will just investigate some methods for selecting a random sample. The TI, that's a Texas Instruments graphing calculator, if you have one now, which I doubt many of us do, they have what are called random number generators. Okay, I'm also going to show you on this, or introduce you to, in this video, a random number generator that you can find online. And I'm sure there are many others, but this one is easy, very simple, and it's what we call an applet. It's just a small little applet, like applet, very tiny app that you can find online. Choose your parameters, and we'll talk more about that later, and select your numbers. If you're not able to get onto that website, which I'm sure most of you can, you can go ahead and write the numbers 1 to 150 on small slips of paper, something like I've been doing in this module during this module as well, which is a real hassle, but you can do that. Okay, an old technology, pencil and paper, still very useful. Okay, well, let's go ahead and and start this lesson off here with the quote-unquote classwork. Okay. And it says here, it opens up, in this lesson you will obtain random numbers to select a random sample. Okay? You will also design a plan, design a plan for selecting a random sample to answer a statistical question about a population. And that's exactly what we're always doing. We're answering statistical questions about a population. We have statistical, question, population, the three main words in that sentence. Okay, so yeah, well, let's go ahead and get started and ask this question right here. And an interesting question indeed, especially for you bookworms out there. Example 1 is sampling children's books. So, what is the longest book you have ever read? Now, this is not in terms of pages. In this case, we're talking words here. And The Hobbit, if you've read The Hobbit, believe it or not, you read 95,022 words, which is not hard to believe, knowing Tolkien, and those of you who have read The Hobbit or Lord of the Rings books, lots and lots and lots of description. On the other hand, or we say on the other end of the spectrum, The Cat in the Hat, 830 words. Okay, so quite a short one. And those of us who have read little children's books, and when you're first starting off, little read-alouds with your mom or your teachers, words not even topping the teens, of words. But popular books vary in the number of words they have, not just the number of different words, excuse me, but the total number of words. The table below shows some interesting statistics here. The total number of words in some of those books. The histogram, which we're going to look at in a second, displays the total number of words in 150 best-selling children's books with fewer than 100,000 words. Okay, so we're looking at fewer than 100,000 words, which are most, if not all. And there we go. You could take a look here. Maybe some of your favorites. Black Beauty, 59,000 some odd. Catcher in the Rye, very popular one in high school that you'll be reading. Tom Sawyer, nearly 70,000. Secret Garden, 80,000. I'm sure some of you have read that one. And you can see on and on and on and on. Let me look for another one here. Green Eggs and Ham, 702. Yeah. Treasure Island, Magic Treehouse, Lions at Lunchtime. So you can look at that. So like a second, third, fourth grade book about 5,300 words. Here's our Harry Potter again, coming close to The Hobbit, and it's 80, nearly 90,000 words. So, yeah, you can see these are a lot of popular books here, and the number of words in them. Okay. Okay, and here's that histogram again. And if you had forgotten that term, we talked about it probably briefly in a lesson or two beforehand. But a histogram, uses an x and a y axis, as you can see right here along the side is the frequency. Okay, and the frequency in this case are the words. Okay, the number of words. And what you put here, and this is the number of words right here, but this is the number of, and to say frequency, this would be the number of books that fit into that category, okay? And they don't put that here because a histogram very traditionally or normally just uses that word frequency, okay? It's more or less a frequency graph, okay? And it just tells you they took 150 best-selling children's books and they said here how many have at least 5,000 words, and over here how many have, well, not at least, probably up to 5,000 words there. And here how many have up to 100,000 words right there at the end, okay? So, for example, something with 95,001 words, okay, would be in this histogram right here, or this bar, okay, because it's just over 95,000, which is that bar there, okay? So that is a histogram. So these you can see right here, pretty clearly right here, this 15,000 words bar is 5, so there are 5 books here, okay? 5 books that were up to, or between, let's say 10,001 words and 15,000 words, okay? So if you added up the total of all these bars, this one's probably about 26, this one's 25. Okay, if you added all of these up, they would equal 150 total books, okay, because that's what they used, okay? So again, I'm not sure we've ever talked about how to read a histogram. It is different, okay, and it can be very confusing, and I'm sure I get a real strong sense it might be something you'll be seeing on some testing in your lifetime, okay? All right, so here we go. Here's that histogram. We're going to use that histogram here to answer these 2 questions here, exercises 1 and 2, okay? So from the table, choose 2 books. Now this is on the other side. The table they're talking about here is this the table over there. From the table, choose 2 books with which you are familiar and describe their location in the data distribution shown in the histogram, okay? All right, so this is something I'd like you to do, okay? And if you know what that means, go ahead and do that, okay? If you don't know what that means, I will explain that to you. So I'm going to pause here, and I'm going to have you do that if you understand what I'm saying, understand what this question is asking. If not, again, we're just starting. We're just pretty much just learning how to work with these histograms. Okay, so if not, I will of course go through one. Okay, so 2 books I'm going to choose. I'm going to choose The Catcher in the Rye. Okay, and The Catcher in the Rye again was a favorite book of mine in high school. 73,404 words. Okay, and then Charlie and the Chocolate Factory, and I really did enjoy Roald Dahl's children's books. A little irreverent, a little naughty, but funny and actually quite sweet in the end, usually, all the books. And that one, 30,644 words. So let's go ahead and look at where they would have a place on that histogram. Okay, so Catcher in the Rye here at 73,404 words. Okay, that one is going to end up in, and maybe you can figure this out as well. Okay, but yes, it's going to be in this bar right there because it is in that range. It goes from 70,001 pages through 75,000, okay? So it's more than this bar, and it's less than this bar, so it's going to go into this bar right here, okay? So that's where that Catcher in the Rye would fit, okay? Again, really important how to learn how to read this histogram or work with this histogram, and that's a big part of the battle when you're reading statistical charts and graphs is just knowing how to do it. You know, it's really not all that difficult once you have the procedure in hand. Okay, so now Charlie and the Chocolate Factory here at 30,644. Okay, is going to go in this one right here. Okay, that one right there, this bar, because it has more than 30,000. And then less than 35,000, so it's going to find its place in here. So it's one of what it looks like maybe about two books that actually fit into that on that bar. Okay, and you can see right here there's nothing actually came in this bar. You can see a couple bars actually, or a couple actually ranges were not occupied at all. Okay. So I'm not sure, of course, again, we're not in class, can't see you, can't talk to you, so I don't know which books you chose, but I hope you did indeed do this correctly, and if not, you do now understand where your books would have been, would have fit in this histogram right here. Okay, so let's go ahead and look at number 2 here, and it says, put dots on the number line below that you think would represent a random sample of size 10 from the number of words distribution above. Okay? I just read that sentence and I don't know what that means. I'm going to read that again nice and slowly. Put dots on the number line below that you think would represent a random sample of size 10. Oh, okay, so a random sample of 10 books, okay? Jeez, of size 10, that's like a shoe size or something. Okay, this is 10 books. Okay, 10 books, all right. So, all right, what we're going to do here then, we're going to look at this number line, and again, this isn't making sense to me because I don't see the number line in front of me, but you see a number line, I'm sure, in your pages, and on the next page of my presentation here, that number line will appear. Okay, so we're going to go ahead and put dots on the number line below that number line that you think would represent a random sample of size 10 of 10 books from the number of words distribution above. Okay, so let's go ahead and take a look at that. Well, if we look at this number line here, it only goes up to 10,000 words. Okay, so if we were to go ahead and look at our number, the distribution of all those words over here. If we took a look at this, all these books here, for example, okay, this is not the full 150. Actually, the full 150 we can see here. Okay, we would look. We're only looking up to where 10,000 words, which is just right here, okay, these two right here, okay, and we have how many books in there? About 20 to about 45, 46, so 46 books there, and it looks like more towards the 5,000s. So if I were to make little dots, I'd probably put a bunch here. I'd probably cluster, and again, this whole prediction idea, I'm not sure we're doing much of this later on in this book. But again, we're not going to go over 10,000, of course, because this only goes up to 10,000 here. But anyway, your answers are going to vary, but I would think there would be more of a cluster towards the middle or the higher values here, because, just because. I don't know why, because. Okay, well, let's just move on here. Sorry. Here we go, example 2. Now, using random numbers to select a sample, okay? So the histogram indicates the differences in the number of words in a collection of 150 books. So, how many words are typical for the best-selling children's book? Answering that question, okay, that question would involve collecting data. Okay, so to answer a question, you collect data. And there would be variability in that data. Okay, what does that mean, variability? Well, variability means difference. Okay, there would be differences. All right, so it's a statistical question because of that variability. Okay, there's going to be differences when you collect once or when you collect another time. Okay, you take a sample, one sample of 10 books, let's say, then you take another sample of 10 books. There's going to be variability. Okay, that becomes a statistical question because we're talking about chance and probability, etc. Okay, so if you think about the 150 books used to create the histogram above as a population, okay, that's what you're going to do here. So you're going to think about that. If you think about that, how would you go about collecting data to determine the number of words, the typical number of words for books in this population? So how would you go ahead and collect data? What would you do first? Think about that and write an answer down and come on back. Actually, answer that question and also think about this. How would you choose a random sample from the collection of 150 books discussed in this lesson? So think about those things. Well, you actually probably shouldn't have answered both these questions at the same time because one would exclude a couple of the others. So, for example, I mean, this first one here, if you're just going to answer this one, how would you go about collecting data to determine the typical number of books in a population? I mean, one thing you could do is you could add up page totals. I mean, add all the pages from all those books and then divide, okay, and then divide by number of books. Okay, so what do you get when you do that? What do you get when you add up all the pages and all the books and then divide by the number of books? You're going to get, of course, you're going to get an average, okay? Or, in statistical parlance, is usually called the mean, okay? So you could get an average or a mean number of pages, and that could work out, okay? You could also get something called a median. We've talked about that, okay? A median number, all right? You could line up all these books from the shortest book to the longest book, or the least number of words to the most number of words, and then you can find that one in the middle, okay? So that middle value would be your mean, okay? So, median, okay? So you could do that. You could do that. But the truth is that's probably not, though these are statistics, absolutely statistics, okay? What we are going to do, of course, is, since this title of this lesson is about random samples, okay, we're going to go ahead and choose a random sample. Now, how would you do this? How would you choose a random sample from the collection of 150 books? Well, you could indeed number all the books, throw 150 pieces of paper in a hat, and pick, okay? Or you could even write the title of the book down, okay? Throw them in a hat and pick them out, okay? Now, are you going to, if you're going to do it that way, let's say you put every book into a hat on a piece of paper, you're going to pick one out. Are you going to return that back to the hat? No, okay, so this is going to be without replacement, okay? So without replacement, you would pick those titles out of the hat. And of course, there are other ways, all right? And these are the ways that we're going to discuss right now, okay? Discuss right now some other random sample selection possibilities. Okay, so the data for the number of words of the 150 best-selling children's books are listed below, okay? So we're going to go ahead and select a random sample of the number of words for the 10 books, okay? And the way we would do this, okay, would be, and again we talked about this, slips of paper, okay, or random number generators, etc. You could do slips of paper if you wanted to, but I'm going to say we go ahead and wait on that. This is real easy right here. Just this chart right here is going to be able to help you out. So, for example, I'm going to show you in a minute, pretty sure here. So we're going to go ahead and turn you on to this random number generator. And I'll actually do it off to the side here. I'll generate some numbers here while we run this lesson. But for example, if you picked the number, or your random generator, or you picked in a hat example, for example, the number 17, okay, if you picked number 17, then you would go to this row right here, okay, this row right here, okay, because that's where books 11 through 20 are, so this would be 11, 12, 13, 14, 15, 16, 17. So here's book 17. Okay, so you're going to, so you would generate, that would be your first pick, then you would write that down, 88,252. Okay, and again, like I said, no replacement. That stays out. That number 17 stays out. Okay, because you don't want to choose it twice in this case. Okay, you don't want to choose it twice. We're collecting a random sample here. All right, so that's how that would work. Okay, so for example, of course, book number 1 is here. Book number 150 is here, and I think you get the idea. Okay, so let's go ahead. I want to just show you now this random sample generator and random number generator. And if you can, it'd be great if you would open up a new tab on your computer, if that's where you are, or if you have a second computer or something to have by your side to look at both at the same time, both this lesson and this random number generator, or just go back and forth. Okay, so here is a picture of this random number generator here, and this random number generator is at this this address right here. Okay, if you could write this down, or just go ahead and open up a new tab and enter this right here. Okay, so you can see there it's www.rossman, that's ROSSMAN, chance, okay, rossmanchance.com / okay, applets, APPLETS / random gen, and again these are all case sensitive, so there's going to be a capital R and then ANDOM and then a capital GEN / again, and then you're going gen random, again paying attention to the uppercase G and R, O1.htm, hit enter, okay, and you should come up with something that looks like this, Rossman Chance Applet Collection here, okay, and it's a generate random numbers, okay, and I'm going to go ahead and tell you about how to do that, okay. So go ahead and find that and work until you are able to actually get to this page. Okay, so once you're here, okay, I'm not exactly sure what all these numbers are going to look like on yours right here, but let me just tell you what we need to do, okay. So right here, you're going to keep this as number 1. Okay, this is going to be number of replications, just 1. Okay, let me just cross all this out to confuse you, because that was just something I had generated when I had turned this on initially. Okay, so I'll cross that out. So yeah, you want that number of replications to be 1. Okay, numbers per replication. Okay, and that is going to be 10. Okay, so we want 10. We want 10 numbers generated. That's pretty much what we're going to have. Okay, so that's a 10 right there. Okay, 10. And then the number range, of course, is going to be from 1 to 150. Okay, so you're going to put 150 in this second one here. Okay, because that's what we want. We want to go from 1 to 150 because we have that sample of 150 best-selling children's books. Okay. With replacement, you're going to click on that and say no. Okay, so I think it defaults to yes, but we want no replacement because we want just one of each. Okay, sort the results. I would go ahead and say yes. Okay, and make it a little bit easier. Okay, make it a little bit easier there. Just put yes. It'll put them in, and you can choose from, it'll tell you 1, 2, 3, or 3, 2, 1. That doesn't really matter, but I would choose just 1, 2, 3. So you go from the smallest number to the largest number. Okay, so once you have that set, go ahead and then you would click on generate. Okay, click on the generate, and then it'll give you a list of numbers. I'm going to go ahead and do that right now on a computer next to me, and I'm going to show you what came up for me. Okay, so here's what I got. Okay, I got 7, 15, 23, 52, 59, 68, 70, 77, 82, 118. This is really, what a great way to generate random numbers, huh? Okay, and again, this is all random. Okay, this generator, this random number generator is just programmed to pretty much pick whatever comes up. Okay, and you can see it kind of, even though again this is all random, it kind of lumped a lot of them in this one little area here, this middle area, 68, 70, 77, 82, not too far apart, but again it's all random. Okay, there's been no bias here. We haven't selected, we haven't made, we're not picking pieces of paper, which is still okay. Okay, but hopefully you guys were able to use this and generate your own random samples here. Okay, so again, here is my random sample. All right, so we're going to go ahead and do something with these random samples right now. So again, if you want to just go ahead and generate another one, if you haven't yet generated one or you're having trouble generating, just go ahead and use my my sample here of 10. Okay, and if you want to, just pause and maybe write these down somewhere, because we're going to go back to the page in the binder to actually apply or use these numbers. Okay, so yeah, let's go ahead and do that. Okay, so I'm going to start you off and just show you how to use these random numbers, and I'm sure there's at least a few of you out there who have figured this out already. But for example, so here's my list of random numbers that the generator picked for me. Okay, I put them up here. So number 7, okay, all I need to do now is go back to my list of books here and find, let me go ahead and erase all these here because I'm not going to use any of those. Okay, this was just an example. Okay, I'm going to go ahead and find my 7. So number 7 is going to be in this front row, this top row here, because it's between 1 and 10. So I go 1, 2, 3, 4, 5, 6, 7. Here's number 7. Okay, so I have generated my first random book. Okay, I don't know what that book is. Okay, because I'm only concerned about the words right now. Okay, number of words. All right, so my first, I'll go back and get that, 92409. Okay, so I'm going to get my list here. So 92409. Okay, there we go. That's my first book. Okay, my first number of pages. And why don't I put like a little, maybe a semicolon in between these, because I have commas in them already. Okay, and then I'm going to go ahead and find book number 15. Okay, I'm just going to do one more, and I'm going to have you do the rest. Okay, now you can either be generating your own, okay, or you could just use mine, just so we could all be on the same page and create the same. But it doesn't matter. You guys could be doing this yourself as long as you know what you're doing is correct. Okay, so I'll just do one more. I'm going to go for book number 15. Book number 15 is going to be in this row here. So 15, so this is going to be 11, 12, 13, 14, 15. Here's 15. Okay, so that's going to be 81450. That's my next book, 81450. Okay, a little semicolon there. All right. So there you go. So I'm going to have you go ahead. I'm going to finish up mine. Okay, I'm going to pause, finish these up. No sense me wasting your time here. But you go ahead and do the same there at home. Okay, and come on back again if you want to use my numbers. You can, my randomly generated numbers, or use your own. Okay. All right. Go ahead and do that and come on back. Okay, so here are all of the randomly selected books that I picked. I picked some big ones too. I mean, look at this, at 92,000, and then 81,000, 75,000, 66, 84,000. Boy, some really, really large ones. Just a couple of, none of the real small ones. So again, this is just random, and again, there is what we call variability. All right. So I've written all those down here, and again, you can see these are some pretty sizable books. Look at these sizable ones. Wow, all the pretty big ones, and the other couple were just in the thousands, right? So there is my list of random numbers of words in books. Okay, again, I don't know the books, the titles. All I know are the numbers of words. Okay, so now what it wants us to do here is to choose two more different samples of size 10 from the data and make a dot plot for each of the three samples. Okay, so we have our first sample here. They want us to collect a second sample, okay, and then a third sample. All right, so what I'm going to do right here, right now, for you is to go ahead and generate. If you don't have your number generator at home up on your computer, weren't able to access it, I'm going to go ahead and generate two more random samples of numbers. I'm going to write them here, and this way you can go ahead and find out which numbers correspond to those, on this table here, okay, and then we'll go ahead. And again, there could be a repeat now of these. All right, now because we're going to take a whole brand new sample. Okay, so there could be a repeat. One of these numbers up here could repeat. So, all right, that doesn't matter. But then we'll go ahead and we'll make three different dot plots. Okay, we'll do a dot plot on this one here, and then we'll make another dot plot and another dot plot. Okay, and we'll just compare those. All right. Okay, which may eventually seem tedious, but yeah, this is helpful to do these things. So let's go ahead. I will go ahead and do that. Generate two more random samples, using the numbers 1 to 150, and you can go ahead and find the corresponding numbers from that chart. Okay. All right, I'm going to go ahead and do that. But if you don't want to wait for me, whatever, you can go ahead and generate your own numbers. I think it's a lot of fun. Okay, so here are my two more random samples of 10 different numbers, 1 to 150. Okay, here's that random sample 1, or actually number 2, the second one, and then random sample number 3 right there. Okay, so go ahead and find, just like we did up top here, find the corresponding numbers from the chart that go along with those numbers from the random sample, and write those down right there somewhere or wherever, and give yourself enough room where we can make some dot plots. Okay, so go ahead and do that. I will do the same. If you don't want to do that, you can just come back here, because I will have done it for you, because I serve you. Okay. Okay, so down here you can see here is up here is sample number. This was our random sampling number 1. Here's our random sampling number 2, and then this last was a random sampling number 3. Okay, so 3 different ones. Now I just noticed that, I don't know, I'm not sure if your dot plot looks similar to mine, but this one is actually not going to work. Okay, because it only goes up to 10,000. I'm not sure why it's not on here, but I'm going to go ahead and make a dot plot that will fit up to 90,000 words, which is what we need for our top. Okay, I'm going to go ahead and do that. You can do the same if you want to just wait for me to come back and copy mine. You can do that. Okay, so our next step then would be to go ahead and make a dot plot for each of those 3. Okay, so we're going to make a dot plot for number 1, 2, and 3, and get rid of all this. This was just our random sampling. And what do you think of that random number generator? I love it. I don't know. I hope you guys like it as much as I do. I think it's a lot of fun. But anyway, I'm going to go ahead and draw 3 lines, and we're just going to get a general idea and create dot plots and just look at them and figure out what they mean, what they're telling us, if anything at all. Okay? All right, so I'm going to do that. If you want to do the same, you go right ahead. Again, I realize there's not a lot of calculations in this kind of math, but it is a bit tedious because it is time-consuming when you have to put together graphs and plots, etc. Okay, so here's my dot plot number 1 here, and if you notice what I did down here is I just put these in thousands here, just to save room. Really difficult to write the whole number out. So 10, 20, 30, 40, 50, 60, 70, 80, 90, that they all stand for thousands. Okay, so thousands of words. And you can see there's my first dot plot using all those. You can see they kind of, if you notice here, kind of, like I was saying before, kind of clustered up here towards the top. You can see. Now again, this is a random sample, but again, there's that variability. Now let's go ahead and take a look at, I'm going to go ahead and dot plot sample number 2, okay? And I'm going to come back. Actually, I'll do both of those and come back, 2 and 3, okay? Okay, so here, here are my other 2. I guess one thing you do notice really pretty starkly here is the absence of any books in this range here. Right there. Actually, with these 2, it's like really hard. There's none. Absolutely none at all. There are a couple actually in that second. But still, a clustering here, clustering here, clustering here. And actually at the ends as well, I mean, more or less. Okay, you can see that there seem to be 2 extremes here when we picked out random samples. Now again, this may look very different. I mean, there is a chance you could cluster in the middle, you know, in some random sample. But so far, this is what what it looks like. I'd really love it if you were doing it yourself, generating, excuse me, generating your own random samples and coming back and doing them, and it'd be really interesting to see. And again, in the classroom, much more interesting. We can see all of us, like 14 of us, doing this on our own and seeing some really interesting results. So here are a couple of questions to consider here. If your teacher randomly chooses 10 books from your summer vacation reading list, would you be likely to get many books with a lot of words? Explain your thinking using statistical terms, okay? Using statistical terms. So if your teacher randomly chooses 10 books from your summer vacation reading list, would you be likely to get many books with a lot of words? And I'm assuming that that is your summer reading list, that sample of that whole population of 150 of the best-selling children's books. Okay, so go ahead and think about that and come on back. And the place we would look to answer this question would be these 3 samples. Okay, again, just based on our sample, our collective sample, which is just me doing it. You can see there's a pretty good chance, like we had mentioned, that you're going to get a book up in this range. So a book with about, I don't know, 70, 80,000 words. Okay. You might get one that had more words. Okay. Probably very unlikely, it seems, based on this sample, that you're going to get any book in this range. Again, we did just talk about that. So again, using a sample, and again, using sample data, you know, statisticians rely on this sample data, but it's not necessarily, again, a perfect science. Okay, it is not. Okay, but using in statistical terms, since we see a clustering at these ends, you're looking at, boy, a good chance that you're going to get at least a few books from this between 70 and 90,000 words, okay, and probably a couple under 10,000 here, okay? All right, so in statistical terms, using these statistics to answer this question, that's what we pretty much would have come up with, all right? So next here, if you were to compare your samples to your classmates' samples, do you think your answer to exercise 5 would change? Why or why not? And yeah, that would be this answer right here. Okay, would it change? And again, and it could. I mean, it could change. All right, because like I said, there is a incredible amount of what we call variability in this data that we collect, okay? Variable, I mean, that's change, okay? Lots of variation, all right? You could, you know, somebody's statistics or somebody's dot plots could have looked much different than mine do here, okay? I could do this another 5, 6, 10 times, and I may have similar groupings, okay? Similar groupings. But this here, it's variable, and yeah, your answer could have changed for that, or maybe not, okay? Again, this is the perfect imperfection of statistics, all right? Okay, so the balance of this lesson here is exercises 7 through 9, and they're calling it a statistical study of balance and grade. For our purposes here, since we are not in class and we don't have you available to actually complete this study, because it is a lot of fun to actually go ahead and collect a sample and collect data and create your graphs, etc. A lot of fun to do that, but since we can't do that because you know, of logistical constraints, we're just going to go ahead and you're going to go ahead and plan this by answering these questions that follow, but we will not follow through with the actual study itself, okay? But anyway, number 7 here asks you, is the following a statistical question? Okay, again, thinking and regarding statistics. Is it a statistical question? Okay, here's the question. Do sixth graders or 7th graders tend to have better balance? Okay, why or why not? Is this a statistical question? So if you're going to ask yourself, it's a statistical question, you're going to ask yourself a couple of things. Can you answer this question by collecting data? Can you collect data on this? Okay. Would there be some variability on the data collected? Would some people have better balance than others? All right. Okay. So answer that question. What do you think? Yes or no? I'll wait. Okay. I'm still waiting. No, of course. But yes, it is a statistical question. Okay. It is a statistical question because we can collect data. We can have 6th graders and 7th graders do balance tests, okay? And we can decide what type of test they are, maybe standing on one leg with their arms crossed or hands out in front of them or hands out to the sides. And we could do a number of things, a number of balance activities. We could see how many seconds they can stand on one leg, for example, and then record those. Okay, so you have to be able to collect data. Okay, and to have that data be more or less quantitative. So we say quantifiable. Okay, quantifiable. We want to put a quantity to it. Okay, and so in terms of this, it could be how many seconds can you balance on one foot. All right. Okay, so continuing on here, Berthio's class, class decided to measure balance by finding out how long people can stand on one foot. Wow, I did not read ahead, okay? But it made sense, I guess. So how would you rephrase the question above to create a statistical question using this definition of balance, okay? So think about that, because I need to think about that, but I don't want to think about that while this machine is on here, because I'm just taking up your time. So I'm going to go ahead and pause while you think about this question. How would you rephrase the question to create a statistical question? Okay, we want a statistical question, all right? So go ahead and think about that and come on back. Well, this question will be a simple one. Can sixth graders balance longer on one foot than seventh graders? Could be our statistical question. Now, what's really interesting about this, and we won't get into this probably at all when we talk about statistics here in seventh grade, but there's something called the null hypothesis, okay? And the null, you know what null means? Actually means like not or none or none or nothing, okay? So null hypothesis. So the null hypothesis here, again, I won't linger on this too long here, but very interesting thing to think. A null hypothesis is always that there's no difference. There's no change. So the null hypothesis here would be sixth graders and seventh graders can balance the same time on one foot. Okay, that is the null hypothesis. So it's like nothing will change, nothing is different. But then you have an alternative hypothesis, something you can use, and you would say, well, which one? Would it be yes or no here? You could say no, since you are a seventh grader, most of you out there. No, sixth graders cannot balance longer than seventh graders because seventh graders are more mature and have a greater sense of balance. Okay, you may use that as your hypothesis, but that's besides the point, because we're not dealing with hypotheses now, hypotheses right now, but this question right here, which is the answer to the question, would be very simply a question that we can quantify. We can collect data. We can collect data in minutes, in seconds, etc. I doubt hours anybody's going to be balancing on one foot, okay? And we could actually make a max. I mean, we could say, up to after 5 minutes, it's done. 5 minutes is your max, because that might save a lot of time when you're collecting this data, because you may have some super balancer out there who can actually stand on one foot for a long, long time. All right, here we go. Next question here is, what should the class think about to be consistent in how they collect the data if they actually have people stand on one foot, okay? So how they collect the data, what do we have to be consistent? This word is so important when it comes to statistics, when it comes to any scientific endeavor as well as science experiments, experimental design. Really, really important to be consistent. What do we need to think about, okay, to make everything consistent? Okay, so think about that and come on back. Once you start thinking about this, it becomes a little bit more complex than you actually think to make what we consider to be a fair test or a consistent test, right? For example, which foot? Okay, which foot will people be asked to balance on? All right, I mean, is it fair to have someone who feels more comfortable on their right foot balance on their left foot? I don't know. Maybe we could have it vary. Maybe people can choose their better foot, okay? Or maybe we can have them balance on both, the left and then the right. Take an average of the two. Okay, how high off the ground? How high off do you want their foot to be? I mean, can they actually prop their foot against their other leg? Okay, that kind of thing. Or is it barefoot? Do they do it barefoot? Do they do it with the tennis shoes on or sandals, for example? And the instrument used, what are we going to measure with? Are we going to measure with a stopwatch? Are we going to count? Yeah, I would say, to be more precise, be stopwatch. When do you actually stop the stopwatch? When their other foot hits the ground, or when they start to stumble? Lots and lots of questions to think about. Just sounds so super easy to run this experiment or run this study when there are a lot of things to ask ourselves, okay? Okay, so the rest of this, number 9, is, we could just talk about this real briefly right here. Of course, you're not together to actually talk together to plan this sample or random sampling. So it says here, work with your class to devise a plan to collect a random sample of 6th graders and a random sample of 7th graders to measure their balance using Berthio's method. Okay, I'm just thinking what might be, well, actually, why don't I go ahead and let's just finish this out. Okay, then we're going to, of course, they wanted you to write a paragraph here. All great stuff, okay? Great stuff. Love it, love it, love it. Not practical for our purposes, the way I'm putting this out to you here. So the population, of course, answering these questions. What is the population? Of course, the population are all the 7th graders, all the 6th graders in your school, okay? how will samples be collected from the population? If you think about that, how would you like to do that? I love the random number generator. Maybe just apply a number for each person in the class. Let's say they're 7th graders, numbers 1 to 30, and then set our random number generator to just generate 10 of those numbers, okay? And we can choose those people. All right, why is it important to be random? Okay, this is something I'd like you to think about. And again, I'll tell you again, random samples are always the most reliable because they have as little bias as possible. Okay, so I mean, sometimes random samples can be biased, but in this case, if you have a population of 37th graders, that's the entire population, then you randomly sample from them. You have included everyone. Everyone has the same possibility or probability of being chosen. So you've eliminated bias, and bias is what can really create bad statistics. Okay? How would you conduct the activity? Well, these are things to think about. Lots of fun, again, to think about it. Get out there, get your random sample, get your stopwatch, decide on all the parameters here, like we talked about up here, to make it consistent, to make it fair. We could go ahead and sample statistics. Will you calculate? We could do the seconds that they can balance. We could display the data on a dot plot, okay, or histogram if we wanted to, okay. And then in the end here, what would you accept as evidence that there's actually a difference, that you have rejected the null hypothesis, which is exactly how we would talk about this in statistic parlance or statistics vocabulary. Again, that null hypothesis was that there was no difference. Okay, but in this case, what would you accept as evidence that there actually is a difference? Okay, what would you accept as evidence? All right, you'd have to plan that. There'd have to be a certain threshold, a certain number. Okay, if it was so close. Okay, so close, it's really difficult sometimes to actually come to a conclusion when there really doesn't seem to be enough evidence. But you have to decide ahead of time. And again, there are statistical precedents or statistical measures that are set up out there that we're not going to talk about now, that they want you to be as precise as possible. Okay, so again, let's go ahead and just close up. I really hope you find this statistics stuff to be interesting. I really do. Again, if you do embrace it now and have an understanding of what they're talking about, you will find this much, much easier in the future when you come across it again. All right? So again, in this lesson, we collected data on the number of words, selecting a random sample. Hopefully all of you got a chance to use the random number generator online. We also observed how different samples of the same level have some characteristics in common with with the population. The second activity we talked about designing a statistical study. We started going through that statistical process. Of course, we didn't do it. We just kind of thought about it, or I just blabbed here on my side. Okay, and again, some things we're thinking about, and I guess we'll talk about more and more. Again, these activities or these lessons, do call for a lot of cooperation or collaboration within class, so they will have their limits, okay? But as long as we are, you are understanding the statistical vocabulary and the process and the importance of things such as random sampling and understanding that, then we will have been moving in the right direction. Okay? So this is where we'll end. To go ahead and do your problem sets. Hopefully they're understandable to you. If you do need to call or email me, you always can. Okay? And if not, I'll just see you, or you'll hear me in lesson 17.